In this video, we're going to continue looking at z-scores and looking up the probabilities using z-scores, but in this particular case, we need to look at applications in which we have converted values into the normal distribution. So this is like whenever before we were calculating the z-scores. We are now going to use those z-scores to find the probabilities. If you recall that z is equal to the value minus its mean divided by the standard deviation. We want to round z-scores to 2 decimal places because recall on our standard normal curve we have 1 decimal place here and the second decimal place here. It's very arbitrary as to why we round to 2 decimal places. The biggest thing is that's as accurate as our table can be. Okay? So let's look at an example here. A pediatrician attains the heights of her 200 3-year-old female patients. The heights are approximately normally distributed, which is important to know. The mean of 37.72 inches and a standard deviation of 3.17 inches. Lizzie is 35 inches. Find and interpret the z-score for Lizzie's height. Well, if we look at this, since we know that they're normally distributed, I'm going to draw the normal curve over here. And here's the mean of 37.72. Well, Lizzie is at 35. So Lizzie's over here. And we want the probability of her height. So we want this value right here. Well, looking at this, notice 35 is less than 37.72. So when we calculate the actual z-score, we should end up with a negative. So let's look at our formula. It's the value, so it's Lizzie's height minus the mean divided by the standard deviation. So we have 35 minus 37.72, which is going to be a negative 2.72, divided by 3.17, 17, not 14, 17. So Lizzie's z-score is a negative 0.8580, but again, we round z-scores to 2 decimals. So she has a z-score of negative 0.86 because we want 2 decimal places. The third decimal place bumps up that other one. So what does this mean for Lizzie's height? Since Lizzie's height is below the mean, she has a negative z-score. Her z-score of negative 0.86 indicates she is 0.86 standard deviations below the mean. Again, the z-score is, we are normalizing it. We are finding out how many standard deviations a value is from the mean whenever we normalize it in this particular manner. So every z-score is just telling us how many standard deviations is that value from the mean. We can look up the probability if need be. So let's look at example 2. It says the number of chocolate chips in an 18-ounce bag of Chips Ahoy chocolate chip cookies is approximately normally distributed with a mean of 1,262 chips and a standard deviation of 118 chips. according to a study by cadets of the U.S. Air Force Academy. What is the probability that a randomly selected 18-ounce bag of Chips Ahoy contain fewer than 1,000 chocolate chips? So we know the mean, we know the standard deviation. We want fewer than 1,000. So this is the probability that our value is less than 1,000 chips. Okay, so let's look at here. We know that the mean is 1,262. 1,000 is going to be somewhere over here. And we want fewer, so we want to the left. Well, I can't compare these right now. What I have to do is I have to normalize it. I have to find its z-score. So I'm going to come over and look at the z-score. Remember that that's the value minus the mean divided by the standard deviation. So in this case our value is 1,000 because that's where we're comparing things to, minus its mean of 1,262 divided by the standard deviation of 118. 1,000 minus 1,262 is going to be a negative 262 divided by 118. So the z-score is going to be a negative 2.22. So if I look at this, recall that my z is my mean is my 0. Here's a negative 2.2. And we're looking to the left. So the probability that the value is less than 1,000 is the same thing as the z being less than a negative 2.22. So I need to look this up on our table. So if I go back over to our normal distribution table, and I'm looking for negative 2.2, which is here, negative 2.2, and my third digit place was also a 2. So the probability that it's less than that, because it's to the left, is 0.0132. So that's going to be a 0.0132. So the probability of randomly selected 18-ounce bag of Chips Ahoy contains fewer than 1,000 chocolate chips is 0.0132. Now you'll notice that I'm still using the decimal format. I'm not changing this into percentages. It didn't ask what is the percent that are randomly selected. It asked what's the probability. Probabilities are between 0 and 1. Please do not change those into percentages unless it asks for a percentage. Let's look at Part B. Part B, using the same information, so our mean was 1,262 and our standard deviation was 118. What is the probability that a randomly selected 18-ounce bag of Chips Ahoy contains between 1,000 and 1,400 chocolate chips? So if we look at our table here, this is going to be our 1,262. We want that it's between 1,000 and 1,400. So we want in between here. Again, we cannot compare our straight values to each other. And to get our probabilities, we have to normalize them in some way. So I'm going to normalize both of these. So I need to normalize the 1,000. I'm going to subtract 1,262 divided by 118. And I'm going to normalize the 1,400. So I'm going to subtract 1,262 divided by the 118. Well, doing the 1,000, which we actually have already done, we get a negative 2.22. Doing the 1,400, I take 1,400 minus 1,262. That gives me 138. That's a positive, divided by 118. And I actually, with my rounding, I get a 1.17. Because whenever I divided that, I got about 1.169. Changes the 6 into a 7. So I want the probability that we have between 1,000 and 1,400 chocolate chips. That's the same thing as saying that I'm between a negative 2.2 Z and a 1.17 Z. So I need to look up both of these on the table, and when I do, I'm going to have to subtract these values. So if I look up the negative 2.22, well, that's a 0.0132, which we kind of already knew that from previous. So this is a 0.0132. Then I need to look up the 1.17. So I need to scroll down to a positive side. 1.1 is here. And then I look at the 7 column, which is here. So it's going to be a 0.8790. So I'm going to have a 0.8790. I want in between these two, so I have to do some subtracting. So I'm going to take the larger value, 0.8790, and I'm going to subtract the smaller value from it, 0.0132. When I do this, I should get a positive value of a 0.8658. So the probability that a randomly selected 18-ounce bag of Chips Ahoy contains between 1,000 and 1,400 chocolate chips is 0.8658. I had two separate values. I simplified those down into one value with subtraction. Go ahead and try some of these. In the next video, we will continue looking at finding these probabilities. Let me know if you have any questions.